It's 50 states, mate.
It's 3 states.
It's definitely 50. I checked each one.
I also checked the 3 states, and then I wrote the script on the way in just now, and it's definitely 3. I've got a whole plan for 3.
Oh, I think the only way we can possibly compare.
Right to your lists, right?
Yeah,
And then I'll see the 47 I'm apparently missing.
Oh, you will. So first there's the
first one.
Yeah. And then after the first one, there's always
The second one.
the second one. That makes sense.
And then there's the law of gravitation.
Yeah, and then there's Kepler's third law. And Wayne.
I see the mistake we've been making. We were so silly.
I don't know how we didn't notice this before.
There's a dash there.
Yes, Flow Rider.
Flow Rider.
Yeah. Oh, wait, notice another.
Right.
We're talking about completely different things. We're talking about the states of matter.
And you're talking about Clever Cracker Facts.
Yeah, our headquarters.
Our future headquarters of
Yeah.
Clever Cracker Industry.
So, we had one in New York, Flow Rider's house, we're good friends with him.
Yep, the
And-
band slash person
Yeah.
slash whatever it is.
Sash song, I don't know.
I don't know, I liked one of it.
And then McDonald's.
McDonald's,
Obviously.
the best restaurant in the world.
If you really like pound burgers.
And I do.
Or is it Dollar Burger? I don't know.
I don't know.
I don't know
I
either.
haven't been to America, but we will.
We will when we get there.
But what we should probably do is focus on this list.
Yes, so this video is going to be a revision of GCSE and Clever Cracker Trivia.
Clever Cracker Trivia isn't too useful for you, so let's do the gas, solid, liquid thing.
Yes, let's do that. So, solids.
Yeah, we know what they look like from GCSE.
We do. We see them everywhere, and they're quite closely packed, molecule-wise. They can't move around a lot. They only vibrate, but they form very nice lattices, which is not very much like letters at all. Then there's water.
There's liquid stuff, yeah.
Oh, yeah, not just water.
Not just water.
That's
there's
not
other
the only
liquids.
one.
And these are quite tightly packed as well, but they can now move around each other as long as they stay close. A bit like the tectonic plates description, when they slide over each other and then they ping and then everyone dies. So there's liquids.
There's liquids.
And then there's gases.
Yeah, gases, well, they're kind of lone wolfy.
Yeah.
They're about by themselves, moving haphazardly and randomly.
Yeah, those are good words in the mark scheme. They like the word haphazardly.
Yeah.
They actually do.
That's a thing. So, we know what they look like.
Yeah, so that's sort of a revision of GCSE.
Then we have density. So generally, the solid is most dense, then liquid, then the gas.
Which makes
sense because of the spacing. However,
water is an exception to the rule, and there's
Yeah.
probably a few others exceptions as well. There always
Yeah.
is for these sorts of things.
so you know that ice floats in water and ice is the solid.
Yeah.
This is the way the lattice forms in hydrogen bonds. You know chemistry.
You just need to be aware that there's exceptions to the rules, and the general idea that this is the most dense, then it goes down.
Yeah.
You probably know that there's other states of matter as well, so I wasn't quite right when I said 3.
Nor was I when I said 50, but we're not going to speak about those, I don't think, in this course actually.
No, we're not. We're not going to talk about plasma and, what's it, the Einstein thingy, what's it?
Yeah, and supersonics. Yeah, we'll leave those out.
So,
Well, now we know what states are.
yeah, I'm going to give you a very relatable worked example for you to work through.
Always a good thing to do, Wayne. Yeah, relatable. So what have you got?
I've got 920 kilograms of ice.
Oh my, that's a lot. That's a lot of ice, Wayne. What are you going to do with that?
Well, I'm hosting a party next week. It's
Oh,
sort of like
wow.
a barbecue get together.
Oh, so with the drinks.
Cold drink, yeah, drinks.
Really big
We're also
Coke.
going to have like a little ice rink.
Oh, that's going to be great.
Barbecue. The Queen's coming. Simon Cowell's coming.
Oh,
Stephen Fry's coming. All the
wow.
best people.
Can I come?
Clarkson. No,
Oh,
sorry.
sorry.
Your thing. So I've got 920 kilograms of ice.
Okay.
As you do.
As you do.
And what if I told you
Yeah.
that just one molecule of water, just one molecule,
It's one molecule.
weighs 3 times 10 to the minus 26
That
kilograms.
that is quite light.
It is, but you're about 80% water, so if it was heavy, you'd be very heavy.
I would be heavy. That'd be bad, wouldn't it?
You wouldn't be able to jump very high.
No, that's not good.
So what I ask you to do is work
Right.
out how many molecules of water there is in my giant shed containing all the ice.
A very big shed.
More of a palace. The Queen doesn't mind.
Oh, she's used to that sort of
She
thing.
loves it.
So you can't. Counting isn't really an option here.
That would take a very long time and would be extremely difficult.
Yeah, so let's not do that. So we know how many kilograms we have in total. So you have 920 of those.
Yep. And we know how much each one weighs, each individual atom.
Yeah, so we can just
Molecule.
divide.
By 3 times 10 to the minus 26. And that will give you a number.
Yeah.
And the kilograms are going to cancel to give no units, which makes sense because it's
Yeah.
a number of stuff.
And that will give us lots.
Yeah, you can work that out on a calculator if you want. The actual number isn't important, it's the method that is.
Yeah, so we appreciate that's how you do it. Reasonably intuitive.
Another thing they like is a little equation. I put up in the corner, but I'll
Yeah.
draw it up again.
And this is the only thing that's not ever been of GCSE, I think, in the video.
Yeah.
So this is to do with the separation. So you have 1 over x cubed is equal to the number of molecules that there are, where x is the separation between the molecules.
Yeah, so if we take a line, a nice line,
It's a lovely line. Thank you.
and we say that this line is 1 metre long.
Okay.
Okay, so it's not to scale,
No.
it's not a metre long line. But let's say we assume that all the particles are spherical and they line up nicely. The distance between each molecule is x, so the number of molecules along this line must therefore be 1 over x.
Mm-hmm.
But we often don't deal with a straight line of molecules, we deal
No.
with a cube.
Yeah, 3 dimensions, so that becomes cubed.
And then becomes the number of molecules in that volume rather than on that line.
Yeah. And you might be asked to move from one to the other. You might start with the separation, get to the number, and then eventually get to the mass.
Yeah, you can just do that. So if this sort of question comes up, you'd be given that question.
Mhm.
You'd be given that thing. You'd be given the separation, work out the number, go backwards, or you'd be given that and be asked to eventually work out x.
Yeah, but it's just rearranging, and that's relatively simple.
This isn't in your formula booklet,
No.
but it's quite intuitive.
Yeah, if you remember Wayne's little diagram, I think that's the easiest way to do it. Just think of a cube. Yeah,
And there you go. That's
That's
this
that.
in a nutshell.
but we have one last thing, and that's the movement from solids to liquids and to gas. So there was a graph you did at GCSE, and it's quite an important one, especially thinking about the kinetic model a bit later on.
So it's a bit like this.
So we think about water, so it's quite a nice example, so you know that the melting point is 0.
Yep. So this is going to be measured in degrees.
Oh yeah, degrees Celsius, not Kelvin.
And this is 0. This is against time.
Yeah,
This is temperature, otherwise it's T.
so if we start below 0, so you have a solid,
Yeah, we have a very, very cold thing.
cold thing.
Ice cream in the freezer.
Yeah, and we're heating up.
Yep, so over time it's getting hotter. And it reaches 0. So it's now, that is the point where it would have frozen, / the point where it's going to become a liquid.
Mhm. But then temperature doesn't actually increase for a little while, and so it just sort of stays the same, but energy is still being put in.
Yeah, so it's going like this for a short while before going back up again.
And the same thing will happen when it reaches 100 degrees, which is the boiling point, and it will just become flat.
Eventually,
And eventually it will go up again. Yeah.
And we have names for the changing
hmm
from here to here and from here to here.
We do.
Rather than boiling from going from liquid to gas, rather
We
than
have-
saying boiling,
Yeah, we have vaporization instead.
yeah, there's a new word. Or probably a new word. It's new above GCSE, I believe. Vaporization. And from going from solid to a liquid,
Yeah.
we now have the word fusion.
We do.
Rather than, I don't even know what we used before. Melting?
Melting, I
Melting,
think, is
yeah.
the word we used before that.
It's now fusion.
Yeah, and you have to understand what's happening here.
Yep.
All
and
the energy is moving into kinetic energy as opposed to the internal energy, but we'll get more onto that a bit later on.
we've got a video called Latent Heat that will be out soon.
Yeah.
And we go through what these mean in detail in
Yeah.
relation to the kinetic model, which is the next video.
Yeah.
So in a few videos you'll understand this a bit more.
Cool, so I think that's all we need to know about solids.
Yeah. We should probably get on with making those videos.
I think, I thought we were going to sort out the Flow Rider's house.
Oh, yes.